Hello everybody and welcome to the 6th installment in the Aorb Tech NumPy series. Today we're going to be looking at array slicing. In today's episode we're going to be covering row slicing, column slicing, diagonal slicing, and item size. So let's get right into it. So let's start as always by importing NumPy. We can do that by using import, entering NumPy, and running that block of code. There we go. Let's start with row slicing. In NumPy, row slicing has a very simple syntax, which is quite similar to that used in the Python syntax when we are using slicing on strings and lists. When we're using row slicing in arrays, we'll start by using an array, and then we'll use a pair of square brackets. Inside, we'll have the start, followed by a colon, the end, followed by another colon, and the step size. What the start tells us is the index at which we wish to start slicing. From that point onwards, we will carry on to the next element until we reach the end of the array, or until we reach the end size, which will not be included in the slice. That means that if I were to access from the 0th element to the first element, only the 0th element would be accessed. Finally, the step size tells us by how many elements we move each time that we go to the next index when we're slicing. In layman's terms, if I wanted to skip one element between each other element, I would use a step size of 2 because it accesses every second element. Now that we have this syntax, let's see how it works using some code. First, let's create an array. We'll call it array, and we'll use the arrange function to create an array from the first element to the 10th element. We'll print it to see what we're working with. So we have an array with 10 elements inside. Now, let's create another code block, and inside that code block, we're going to do some slicing. So let's create a new variable called slice. And we're going to say slice is equal to our array element. Then we're going to use the square brackets that we talked about earlier, and we're going to access from the first element, or the 0th element. Then we're going to put a colon, and we want to access up to the 5th element. So that should give us the first 5 elements in the array. And now let's print that to see what it looks like. And as you can see, we get the first 5 from 1 to 5. Now, let's create another block of code. Let's create another slice, and this time we're going to call it slice underscore even. We're going to say it's equal to our array variable, and then we're going to slice that array. So we only want to access the even elements of our array. We know that this element 1 is at the 0th position, so we don't want to include that. We want to start from the 2nd position, which means we're going to be using the index of 1. Then, we don't want to have an end position. We want to access every element in the array. So we're going to skip this part and we're going to add another colon. Then, finally, we're going to use a step size of 2, so we skip every other element. And then, we're going to print our new variable, slice even. As you can see, it returns every even element in our array of 10 elements. If we wanted to reverse this, there's a very simple way to do that using string slicing. We'll print our array. Using the square brackets, we'll create a slice. We want to access every element, so we'll skip the first part. The interesting part is when we use the step size. We'll put in a -1. This means that each time we'll move backwards from the last element to the first element. And now let's print what this looks like. And remember that these two colons, since we're not putting anything between them, means that we're accessing the entire array. And the only thing that we're changing is the step size. So let's see what that looks like. And as you can see, we have the same array as before, except that the elements are in reverse order. Column slicing has a very similar syntax, except that we place a colon after the row slice to access the column slice. If you wanted to access a further dimension, you would need to place another colon, and so on, until you reach the desired number of dimensions. To demonstrate this, let's create a code block. First, we're going to create a matrix. We'll use the NumPy arrange function, and we'll create elements from 1 to 25. Then we're going to use the reshape function. And we're going to put those into 5 arrays with 5 elements each. Then we're going to print our matrix to see what that looks like. As you can see, we have elements from 1 ranging to 25. Let's start by doing something very simple. Let's say I wanted to access this column here from 3 to 23, including 8, 13, and 18. Let's create a code block. We're going to access our matrix by printing it. Then we're going to use a pair of brackets. Inside, we're going to skip using the row because we want to use all the rows, so we can just put a column. Or what we can also do is we can put a 0 and then a colon, and that'll access every element in the array. You can also just put a colon. And then what we're going to do is we're going to access the column at the second index. So this would be the column at the 0th index, the first index, and the second index. So now let's see what that looks like. As you can see, it doesn't quite print them horizontally, but it does print the correct elements. So we have 3, 8, 13, 18, and 23, and as you can see, that's the third column from the left. Okay, now let's say I wanted to access all of the middle columns. So that's from 2 to 4 and from 22 to 24. So all of these numbers in the middle here as well. What we're going to do is we're going to print our matrix. Again, we're going to use the square brackets. Inside those, we're going to skip the row section. We're not going to meddle with that yet. Then we're going to put in from the first index to the fourth index, not including the fourth index, and we'll see what we get. As you can see, we get 2, 3, 4, 22, 23, 24, and that's exactly the same as we have here. Let's say I wanted to access every second element. What I would do is print the matrix, use the square brackets, skip the row slicing, and now what we can do is, let's say we start from the 0th element, so we want to include 1, 3, and 5, and we skip the ones in the middle. All we have to do is change the step size to 2, and let's see what we get. 1, 3, 5. Let's also just really quickly cover some row and column slicing at the same time. Now you can kind of think of it as which row do I want to access, and inside each of those rows, which of the elements do I want to access. So let's say I wanted to access every second row, so that'll be 1, 11, and 21. So this row here, and this row here. And inside each of those rows, I want to access only the even elements. So that'll be 2, 4, 12, 14, 22, and 24. So what we can do is we can access our matrix. Again, let's print the result so we can see what we're doing. Now, we're going to access both the row and the column slicing. So as we said, we want to access every second row. So what we're going to do is we're only going to change the step size. Inside each of those rows, we only want to access the even elements. So we're going to start from the second element, or in the first index element, you could say. We're not going to change anything else. The end, we don't want to change the end. And we want to skip every second element. And so let's see what we get. So there are only even elements, and they are the ones that we wanted to access. So from every second row. And there you go. Okay, let's tackle diagonal slicing now. It's a little bit more difficult, but the theory is kind of similar. Instead of using square brackets, though, we will be using a diag function provided by NumPy. Inside, we're going to use a k variable, and we'll place, obviously, our matrix inside as well. And the k variable, you can kind of think of it as like which diagonal do you want to access, and we'll kind of see that visually now. So first, let's start off by creating our matrix. We'll use the arrange function from 1 to 100. And we're going to reshape. We're going to put them into 10 elements, 10 arrays, and let's print it just to see what we're working with. So we have a matrix here with elements from 1 to 100. Now, if we wanted to access this main diagonal here, so that's 1, 12, 23, 34, 45, 56, 67, 78, 89, and 100, what we would have to do, let's first create a code block, is print, since we want to actually check what we're going to do, and then we're going to use the NumPy dot diag function. Inside, we're going to use our matrix, so we're using the matrix as one of the arguments of the function, And inside that, we're also going to say k equals 0. It should always default to 0, but just for the sake of demonstration, we're going to put it here. So that means it will start from the element position 0, 0, if you want to think of it like that. So let's print it and see what we get. So you can see it accesses all of these elements here. Let's really quickly do the same thing. So let's copy this. Let's place it in, and let's change k to 1 and just see what changes. So as you can see now, it's accessing this diagonal over here. So that's 2, 13, 24, 35, 46. You can kind of think of it as moving up by 1 in the matrix. So if we were to change it to 2, it would access from 3 to 4, from 4 to 5, and etc. until we get to the top of the matrix. And let's do one more. Let's try doing a negative k and see what happens. What we'll probably assume would happen is that it would start from 11, 22, 33, so on until it reaches 99. Let's see if that's correct, if our hypothesis is right. And as you can see, that's exactly what it does. So it's actually quite a simple thing. It looks a little bit scarier because we don't use the brackets. We use a function, but it's actually quite simple, and it's quite cool and useful. And finally, we're going to be looking at item size. And what this tells us basically is the number of bytes that each element in an array or matrix takes up. So let's use our matrix that we created earlier. So this variable here, which we called matrix, to make things extra easy. And it should tell us here how many bytes it takes up. So, and that's 8. Okay, so let's really quickly check what that means. Well, let's see what kind of data type each element is being stored as in our matrix. And that's int 64, which means that it's taking up 64 bits, right? So we know that a byte is 8 bits. Let's divide 64 by 8 to see how many bytes each element is taking up. As you can see, we get an 8. So this property here was correct. Thank you for watching. If you like this video, then like, subscribe, share, and hit that bell icon if you want to see videos like this one. We have a GitHub where all of the source code is available for this project and the other projects. We also have a website if you want to see all of our projects that we have for you to do, and for all of our courses. If you want to access our entire course, you can access it on YouTube as well, not only on GitHub or our website. And you can also access our other courses. We have a Python course. If you have no idea what you're doing here and you need a little bit of a refresher on programming, then we have all the basic concepts covered there. So I hope to see you in the next episode, and have a lovely day. Bye-bye.